Now, I would request Professor Sir Shendu De to give his presentation virtually. I think he is in Kharagpur right now, and would request him to give his presentation. Dr. De.
Yeah. So, very good evening to everyone. Uh, at the outset, I would like to express my thanks to Bharat Chamber of Commerce on the occasion of World Water Day. Now, we have already heard from Professor Rai Chaudhary and Dr. Swati regarding the expanse of groundwater contamination, and how contamination in water has been spread in various countries of the world. Now, in this lecture, I will just take a detour, and I would like to address the treatment and conservation of groundwater and industrial wastewater. Okay, so what I'll be doing, instead of providing draft figures and facts, I will be providing some 4 distinct case studies, where I'll be talking about the removal of the arsenic from groundwater in the first case studies. So I have categorized them under the treatment case studies, arsenic and fluoride removal from the groundwater, and then I will talk about 2 more case studies on conservation of groundwater. One is cyanide removal from the steel industry effluent and the water recycling from rice mill effluent. So I will not talk about the health hazard of arsenic in drinking water, because it has been extensively covered by Professor Roy Chaudhary. And also, we all know that more than all the districts along the Ganges in West Bengal and states in India and the plains of Bangladesh, the river basins, they have been adversely affected by the arsenic contamination. Now, I would like to point out the 3 districts on the southwestern part of West Bengal: Birbhum, Purulia, Bankura, and Midnapur, where there is no arsenic contamination in the groundwater. Then we have started to find research why it is so. Then we have found out it is the nature of the soil. The affected district have very fertile alluvial soil. On the other hand, the soil in these 3 districts where the arsenic contamination is not there in the groundwater, they have the strong lateritic soil. This lateritic soil, then we have started to do the research what is the unique property of the lateritic soil, so that we don't have arsenic contamination in these 3 districts. We have found out it is basically the lateritic soil contains lots of iron and aluminum hydroxides and oxides. Okay, these aluminum and iron hydroxides, they are strong absorbent of arsenic. So they absorb arsenic and they do not release it. So therefore, arsenic does not get released from the rocks in the soil, and it will not be released in the groundwater, preventing the contamination of the groundwater in these 3 districts. So what we have looked into, we have started to find out what are the salient features of raw laterite. Laterite is commonly known as the moram, and it is there are vast quarries of lateritic soil available in various parts of West Bengal and Chotanagpur Malbhumi, plateau. So therefore, it is naturally and abundantly available. So the raw material that we are going to use for the arsenic removal, it is not synthetic one. It is naturally and abundantly available. So therefore, it is cost effective. It contains sufficient amount of iron and aluminum oxide, and it has a natural capability for removal of both species of arsenic. Okay, so effectiveness increases several folds after doing suitable chemical treatment. So it has the raw laterite has the arsenic removal capacity. So after doing chemical treatment, we can increase its porosity, and then it will be having more capacity for the removal of the arsenic. And if you have a comparison, the activated alumina is the most common arsenic removal media that has been used several decades, which has a very low capacity, 10 milligram per gram. On the other hand, this treated laterite that whatever we have developed, they have almost 5 times capacity compared to activated alumina. So, and there is no interference from any competing ions like sulfate, chloride, magnesium, iron, bicarbonate, carbonate, whatever are present in the groundwater. It works a wide pH range between 5.5 and 8. And the most important feature is it satisfies the toxicology leaching protocol. That means once its life will be over, the media binds arsenic by strong chemisorption. So even if you just leave it open under normal atmospheric conditions, the bound arsenic does not leach out from here and recontaminate groundwater. It does not do that. Okay, so it's really a green solution. And since its capacity is very high and we are chemical engineers, we can really design a adsorption column so that there is no regeneration required during its lifetime. Its lifetime will be minimum 3 to 5 years. So during its lifetime, the bed is not required to be regenerated. So it basically eases up the operational maintenance problem. The recurring cost to be very, very low. So these are some of the key features of the filter that whatever we have, I have summarized in this slide. It has a very strong, very high removal capacity of arsenic, 46 milligram per gram. It is one of the highest among the naturally occurring media. Arsenic concentration in the filtrate is within 10 ppb microgram per liter. That is the WHO prescribed limit. So after filtration, its concentration is less than 10 ppb. It is capable to remove iron below its permissible limit. Actually, for any adsorption-based media, one has to, put up an iron removal unit at the upstream. Otherwise, the whole filter will be choked. So, in the same unit, we can remove iron, arsenic, and bacterial contamination because laterite itself it contains lots of iron compounds. So, they are the they can remove the bacteria. It is highly scalable. It can be scaled up anything between 500 liter per day to 50,000 liter per day. And there is no requirement of external power for the domestic filters. Typically, those are very suitable in the rural areas. Life of the filters is 5 to 7 years, depending on the concentration of the arsenic. And it is a composite bed, contains different layers of activated laterite, treated laterite, carbon, charcoal, fine granular sand, etc. We have calculated the economics. The filtered water comes out to be 1 paisa per liter. So I will be showing some of the snapshots of the filter that we have put up in one of the affected areas in Kashinapur Free Primary School in Rajarhat. Is one of the villages where the concentration of the arsenic in the groundwater is around 100 microgram per liter, 10 times compared to the permissible limit. So it's basically this is the filter assembly where there is an overhead tank. Through the overhead tank we put alum so that the iron gets settled down. From an elevated location, we allow the water to pass through the series of columns which are basically packed with treated laterite, and then arsenic is removed and the water comes and being collected at the bottom tank. These are the midday meal ladies. They take the water for cooking of the midday meal. And there are around 80 students. Capacity of this filter is 500 liter per day. The school requires 250 liters, rest 250 liters. There is a tank, there is a tap outside where the villagers used to come and collect. This filter has been installed in the year 2012, and before lockdown in 2020, till that time it was working perfectly all right. Now the school has been reopened and we have again started the filter. So I have shown some of the results of this filter, performance of the filter. In this figure, first figure on the left hand side, I have given the arsenic concentration. On the right hand side, iron concentration. At the bottom, microbial concentration. Okay, so it is a data of 6 years, 2012 October to 2018 April. All the black dots are basically arsenic concentration in the feed. Red dots are the concentration in the filtrate. And 10 microgram per liter is the WHO limit. If you look into the black dots, there is a fluctuation of arsenic concentration from 50 ppb, 50 microgram per liter to around 225 microgram per liter. This is a seasonal fluctuation. In the rainy season, because of the abundant rain, the groundwater gets diluted and arsenic concentration goes down. But in the summertime, because of lack of rain, arsenic concentration shoots up. And if you look into the red dots, the filtered concentration is always less than 10 microgram per liter. during these 6 years. Similarly, if you look into the iron concentration also varies in the feed from, let's say, 5 to 30 ppm, milligram per liter, whereas the concentration in the filtered allowable concentration is 0.3 ppm, and the red dots show that most of the cases they are very close to 0.3 ppm. And any filter, the microbial, the WHO limit is total bacterial count should be 0. So you can see there are lots of filters available in the market which claims 90% removal of bacteria, 99% removal of bacteria, but still actual concentration by WHO limit of bacteria in the drinkable water should be 0. So if you look into the performance of our filter, although in the feed there are lots of bacterial count, but in the filtrate there is none. Now I have given some snapshots of some of the domestic filters. There have been several such domestic filters have been deployed in various areas of North 24 Parganas and Nadia district. And these are the performance of the domestic filters, 3 years performance from 2012 to 2015. The concentration of arsenic in the feed in this particular filter is around 100 to, even some cases it shoots up to 600 ppb, and in the filtrate all the red dots are lying well below 10 ppb. Similarly, the iron concentration is well below the permissible limit. Now, this technology has been transferred for commercialization to Mandal Precision Private Limited, and they have come up with the community-based filters of 2,000 liter per hour capacity. So till now, they are doing tremendous business in West Bengal and the states of Assam, Uttar Pradesh, Jharkhand. Until now, they have deployed more than 250 filters in these 3 states and of capacity 2 meter cube, 2,000 liter per hour, 5,000 liter per hour capacity, and those are basically for the community scale. And all the filter performance is monitored by the Public Health and Engineering Department laboratories located in various districts. So what are the innovations in this filter? The innovation of the filter is it's low cost without compromising quality of the milk quality. It has a long life, 5 to 7 years. During this life period, there is no maintenance. You need not to regenerate the media. At one shot, it removes iron, bacteria, and arsenic, and the disposal is easy because the spent material does not leach out arsenic, so it can be used for the road laying purposes after its life will be over, after 7 years. So this technology has been awarded for different awards in various forums, and it has been approved by Arsenic Task Force, Government of West Bengal, Department of Science and Technology, Government of India, as well as the Mashalkar Committee of Ministry of Drinking Water and Sanitation. So this technology has been transferred to 3 companies, and commercial, community-based filters and the domestic filters are commercially available. Next case study, I will be talking about the fluoride removal filter. And as Professor Roy Chaudhary pointed out, that those places, those districts or blocks where the arsenic contamination was not there in the groundwater, the fluoride contamination is there. Okay, so I think this has been already talked about, Professor Roy Chaudhary. 5 districts in western part and northern part of West Bengal, several states like Rajasthan, Telangana, Andhra Pradesh, Gujarat, some parts of Haryana, Uttar Pradesh, even Jharkhand and northeastern states, the fluoride contamination is there. And as we have already known, the fluoride contamination, there are 2 types of fluoride contamination: skeletal and dental fluorosis. Okay. So if you do a market analysis regarding the existing fluoride removal filters, they can be categorized in 2 broad categories. One is the membrane-based, like reverse osmosis nanofiltration-based filters, and another is the adsorption-based filters, and mainly by activated alumina and activated carbon. So if you look into these technologies, the average cost of the commercially available filters are quite expensive, 15,000 rupees for the domestic filters. So what we did, we even like arsenic removal, we tried to mimic the nature, and we have found out that why the fluoride is there in the fluoride is arrested in the rocks in a form of hydroxyapatite mineral phase. So what we did, we tried to develop this hydroxyapatite phase in the carbon, so that this hydroxyapatite contains lots of calcium, and this calcium is a potent absorbent for the fluoride. And some parts of calcium we have substituted by aluminum, because one aluminum molecule atom will capture 3 fluoride atoms. Okay, so therefore we have developed a aluminum substituted hydroxyapatite that has been grown in situ into the porous carbon. Okay, and this porous carbon is purchased commercially with a certain characteristics. So this aluminum hap-based phase is grown inside the pores of the activated carbon, and it has shown a very high adsorption capacity of 48 milligram per gram, and it has negligible interference effect with the coexisting ions. And also, if you just leave it, when typically these filters are operated for 5 years, 5 hours a day. After 5 hours, it will lie idle, and during this time, what happens? The apatite phase, which has absorbed fluoride, there will be a surface diffusion of the fluoride in the interior parts of the pores of the carbon. So therefore, the outer surface of the carbon is again available for the fluoride absorption in the very next day. So we call it a auto-regeneration or self-regeneration. That particular feature is obtained in this, observed in this particular absorbent. Therefore, it has a very strong, good performance and a very long life. So we have developed an integrated filter using this medium and installed in one of the households in Bankura district. So I have a data of 1 year data. So it has a fluctuation of the fluoride concentration between 2 milligram per liter to 4.5 milligram per liter. Again, this fluoride concentration in the groundwater increases during the summer days, and fluoride concentration in the filtrate is always less than 1.5 milligram per liter. Okay, so the disposal of the spent adsorbent is also very, very important, because it contains lots of carbon. It has a calorific value of 2,200 calorie per gram, which is quite, although it is less than lignitic coal. So the spent material can be used up can be mixed with 1:20 ratio with the lignite coal, and it can be simply burnt out. And we have also looked into analyzed the ash and the gas. In the gas phase, only 2% fluoride comes out, and it does not make any difference in the aerial pollution. And in the solid ash, the fluoride concentration is very, very less than 1.5 ppm. So even it leaches, it does not make any difference in the groundwater. So a 500 liter per day capacity filter has been installed in Mithila Primary School, Bankura. And again, we had a data here for last few days of when the school was open. Actually, this data is in 2018, but after that the school was closed down because of the pandemic situation, and only in last month the school has been opened. Again, we went there and recharged the material and started the filter to be operated. Okay. So one of the domestic filter that has been installed in one of the household where their child has been affected by the dental fluorosis. So next, I will be talking about a case study where we are talking about the water conservation in the rice mill. Now, in a typical rice mill, depending on their capacity, they take out water from ground every day to a tune of 10,000 liter to 1,50,000 liter. Almost every day they are taking out at more than, on an average, 1 lakh liter of groundwater. There are more than 4,500 rice mills, in different parts of West Bengal, and in Bankura district itself, in Bardhaman district itself, there is around 1,500 rice mills. Just imagine how much groundwater has been extracted in these rice mills. Okay, so what we have developed this rice mill effluent. We have treated, and then the treated water is reused or it is recharged in the groundwater. Okay, so rice mill contains lots of organic material. So we do a alarm treatment where the organic material is deposited and it can be taken out. And after being completely dried out, it can be used as a manure and it can be used as a compost fertilizer. The leftover material, the leftover water is passed through a manganese dioxide coated sand bed through which the leftover organic material are completely demineralized and oxidized. Then it is being passed through a laterite bed and activated carbon bed, where any organic material, any ordering agent, any leftover organic material, they will be disintegrated, degenerated, and then it passes through two carbon beds, and the water being polished, and we get the treated water. Now, every 15 days, there is a backwashing facility here. We have to give a 5-minute pulse, and the filter beds are regenerated. It's very simple operation. No maintenance is required except this, backwashing. It has a guaranteed life of 3 to 5 years, and then we can reuse the effluent or water either for the recharging of the groundwater or reusing in the plant itself. So what we have done, we have deployed a 10,000 liter per day capacity. Initially, we have deployed a 10,000 liter per day capacity on March 18, 2020. That is the just beginning of the lockdown period. We have deployed a 10,000 liter per day capacity pilot plant in Shima Rice Mill in Arambagh. Okay, so that is 13th March 2020. So if you look into all the parameters, the most important parameter is BOD. It is less than 10 milligram per liter. COD, it is not there. TOC, since BOD and COD is not there, so TOC is also not there. But TDS is also removed to some extent. And since one of the filter contains carbon and the lateritic bed, so it's basically lateritic soil, the pH has been auto-corrected. The pH of the water in the rice mill is always 4 to 4 is slightly acidic. But if you look into the treated effluent, so we have data for, and this filter has been operating since 2020, and the pH is corrected, and it is now at the normal, natural pH. Now this rice mill owner, he has requested to increase the capacity to 40,000 liter per day. So only this month in this year, we have upgraded the filter to 40,000 liter per day capacity by putting 3 more columns. And if you look into the physical appearance of the water, this is the raw rice mill effluent, and this is the treated one. And if you look into the economy is very good. So it takes only three rupees for processing 1,000 liter of water. Now, if you look into this, so this table gives the data, first data on 13 March 2020. This is after 1 year, 8 months, and this is this month, March 2022. So if you look into the filter, the performance of the filter is exactly like the same as original filter in 2020. So this technology has been transferred to Electroplaza Projects Private Limited in Kolkata, and they are going to commercialize this. Then I'll present the next case study, cyanide removal from the steel plant effluent. Now, the steel plant contains lots of cyanide, and they are producing huge amount of cyanide, and the cyanide production is pretty high, and they have an effluent flow rate around, let's say, 80 to 100 meter cube per hour. Okay, that is the typical flow rate of Tata Steel effluent flow rate of Tata Steel plant. And it contains cyanide concentration to a tune of 15 to 20 milligram per liter. So Tata Steel approached us to do a project on this, to develop a technology so that it can be scaled up. We did that, and we developed a very simple technology. It's basically, we have to add hydrogen peroxide with a particular dose in the feed solution. At the same time, we do an air bubbling. So in this advanced and in presence of UV light, the whole thing becomes, the cyanide gets degenerated, and it is completely mineralized into the bicarbonate salt, very harmless bicarbonate, and nitrogen gas. So there is no significant amount of sludge also generated in this process. This is a photodegradation method. So we have done a pilot scale study at the Tata Steel plant in Jamshedpur, and it came up very successful. And the discharge concentration is less than 0.2 ppm of cyanide from the 10 to 20 ppm cyanide in the feed. And they came up of a 80 meter cube per hour capacity plant at Ongul, Odisha. So they have taken up a plant at Ongul, in Tata Steel plant. They have come up with a plant of 80 meter cube per hour treatment capacity, and which is successfully running for last few months. And the construction of the plant was delayed due to lockdown, etc. And the plant is very successful. Now they are going to scale it up to 120 meter cube per hour. Okay. So in this presentation, I came to the end of my presentation. In this presentation, I just talked about 4 case studies where the groundwater can be treated to convert into potable water at a very low cost, affordable cost, and similarly, the industrial effluent can be treated so that the water can be recycled back or it can be recharged into the groundwater. So we can address the water conservation problem as well. Thank you very much for your kind attention. Thank you.
Thank you, Professor Sushendu De. And the various innovations which IIT Kharagpur has done and have given the technology to various entrepreneurs is really laudable. I do not know how far the people who have taken this technology could launch it very successfully and could make it a commercially viable project. I am not aware of it. But yes, if these innovative projects are properly marketed, then it's a big service to the nation. Now, I would request our guest in chief, Dr. Kalyan Rudra, to give his address. Dr. Kalyan Rudra.
Thank you, Mr. Saragi. I am supposed to be the teacher of the last period. And being a teacher, I know how difficult it is to teach in the last period. And I understand you are very tired and hungry too. বাইরে গিয়ে দেখেছি খুব ভালো ভালো খাবার আছে, আমি আপনাদের বেশিক্ষণ স্ট্রেস করব না। কিন্তু if I don't speak, chairman will not allow me to go out. So please bear with me. Issue is water. I was reading a book. It was Sir Donald Oster, an American historian. বইটার শিরোনাম ছিল রিভার্স অফ এম্পায়ার. He said, to write the history of human civilization without putting any water in it is to leave out large part of the story. Human history had never been so dry. Water is a free gift of nature. But we are right at this point, water in crisis too. Water in crisis is also the heading of a book written by Peter Glick. When you look at India, how much water do we have? It is about 4,000 billion cubic meter of water which we receive from rainfall. But Government of India estimates an utilizable water. Not that entire 4,000 billion cubic meter of water is utilizable. It is falling in some inaccessible area. It is sometimes we can't tap. So how much we can tap, that is treated as utilizable. Government of India estimate 490 billion cubic meter of surface water and 432 billion cubic meter of groundwater is treated as utilizable. That is, clubbing together, it will be about 1122 cubic kilometer or billion cubic meter. A amount is fixed. This amount is fixed. And population ever increasing. Industry expanding, agriculture expanding, and demand for water is also ever increasing. So per capita available water is declining at a very faster rate. It has created sometimes an alarming situation. If we look at the rainfall pattern of India, আমরা geomorphologically or meteorologistরা বলেন, it is spatially uneven and temporally skewed, meaning that, say, Cherrapunji, Meghalaya having 10,000, 11,000 millimeter of rainfall, while Rajasthan having less than 200 millimeter. This is spatial unevenness of rainfall. And Unfortunately for us, it is skewed also. That is, 4 monsoon months having 80 to 85% of the rainfall what we annually receives. Remaining 8 months having only 20% of rainfall. This is rule of the nature. We will have to cope with this. The challenge of water management has been always been to store the monsoon water and transfer it to the non-monsoon season. This had been the crux of the challenge of water management by the Ministry of Water Resource. But when we look at the map of India, about 1/3 of the country suffers from acute water shortage during the dry months, April, May, etc., etc. About 10 to 12% of the area of the country suffers from so-called excess water, leading to flood. Maybe 270 million people suffer from water stress almost every year. So it reminds me, বোধহয় 2002 সালটা আমার একটু এদিক ওদিক হতে পারে, গুজরাটে ইলেকশন হচ্ছিল। আদবানি যে ইলেকশন ক্যাম্পেইন করতে গেছেন, কিছু লেডিস একটা প্ল্যাকার্ড ধরে দাঁড়িয়েছে, ইট ওয়াজ রিয়েলি ইন্টারেস্টিং। তার মধ্যে লেখা ছিল পহলে পানি পিছে আদবানি। দিস ইজ দ্য ডিমান্ড অফ ওয়াটার. ওয়াটার হ্যাজ অলওয়েজ বিন অ্যান ইস্যু অফ পলিটিক্স in India. So, if you really want to understand the management, you will also have to understand the hydropolitics. So, sometimes these two hydrological extremes is created by the nature. একটা হচ্ছে drought, water short condition, আরেকটা হচ্ছে flood. Flood is the event of July, August and September. And water short condition is the event of April, May. Sometimes we are so optimistic, we think that we can store this monsoon water and transfer it to the long way to the non-monsoon season. If you look the concept of water management, I have listed some of the myths which have guided the water management in India. প্রথম myth কি হলো, we had a understanding, we had a belief that human society is the exclusive custodian of water. What we grossly denied is we denied that water requirement for ecosystem services. আমরা ভুলেই গেলাম যে ওই গাছটা বেঁচে না থাকলে আমি বেঁচে থাকবো না, ওই নদীটা না বয়ে চললে এই সভ্যতা টিকবে না। ফলে we had a misunderstanding. If you look at the Government of India's document, sometimes 1% of the total water availability is described as what we call ecological services. I strongly believe that this is a wrong conception. Every species have right to water, and our existence depends on that. Second is, we had understanding the maximum possible withdrawal of water from the river, and taking it to the long way is the development. Ramaswamy Iyer had been the secretary to the Ministry of Water Resource. এই ভদ্রলোককে ওয়াটার নিয়ে যারা গবেষণা করেন তারা বলতেন ভীষ্ম। হি ডাইড অ্যাবাউট 3 years ব্যাক ইন দিল্লি। আমি তাকে মিট করেছিলাম, উনি আমাকে বলেছিলেন, when I joined Ministry of Water Resources at the young age, I was given an understanding that more water you take away from the river, more you disperse is for irrigation, more you gain, more will be the development. After spending more than 40 years in central service, and after subsequent research, I understand that more water we allow to flow through the river, more we gain. Because rivers renders many apparently invisible services to the society and ecosystem, which science can do. First, it flushes the sediment load and pollution to the deeper sea. Second, it recharges the groundwater. Third, it supports the biodiversity. It helps the floodplain agriculture, and it helps the sediment dispersal, leading to renewal of the fertility on the agricultural field. এই কাজগুলো আর কোনো টেকনোলজি দিয়ে করা যাবে না। Concept of water management initially কি এসেছিল, we can intercept the monsoon water, and countrywide we built more than 5,000 large dams. Jawaharlal Nehru, the first Prime Minister of India, had an understanding that large dams will be the temples for modern India. And we dammed our river. First multi-purpose river valley project had been the DVC. The concept of DVC was borrowed from Tennessee Valley Authority. কিন্তু টেনিসি নদীর সাথে ডিভিসির দামোদরের কোনো মিল নেই. Geomorphologically they are different. So what happened? The Damodar was stemmed with the intention of flood control, irrigation and power generation. If you review after 50 years what DVC has done, if you talk with the local people living in the downstream, they say DVC means Dobano, Bharato and Jobano. This happens, and you will find that every year there is a conflict between state government and the DVC, that they say that the water is being released thereon and leading to flood thereon. Had I been in charge of the DVC, I would not have any other alternative. কি করে DVC takes a calculated risk. এইরকম একটা reservoir, it is normally a 3-tier water reservoir system. Lower tier they called the dead storage. This water cannot be used. This is for sediment trapping. The middle tier they call it the life storage, যেখান থেকে ইরিগেশনের জল যাবে. Upper tier এটাকে বলে flood cushion. If there is a short duration rainfall in September, they will accommodate water here, reduce the downstream flow. This is the mechanism which was supposed to operate. But what happened thereon? The sedimentation was very fast. So DVC authority takes a very calculated risk with the apparently pious intention of irrigating during the borrow. ওরা করে কি এটাকে ভর্তি করে রাখতে চেষ্টা করে, বিকজ সেপ্টেম্বর রেইনফল ইজ ভেরি আনসার্টেন, ইট মে হ্যাপেন, ইট মে নট হ্যাপেন. এইবার যে বছর সেপ্টেম্বরে ক্লাউড বার্স্ট হলো না, দে উইন দ্য গ্যাবলিং. আর যে বছর হলো, দে আর কম্পেল টু রিলিজ ওয়াটার, রিজাল্টিং এ ডিজাস্টার ইন দি ডাউনস্ট্রিম. Actually, they don't have any other alternative. Otherwise, there would be a dam burst, leading to more and more serious consequences. So this is the system-embedded weakness of the large dam flood control system. Second is power generation. DVC largely produced the thermal power. But what was the optimism? It will produce hydropower. The same dam cannot produce hydropower as well as ensure irrigation. Irrigation means storage of the monsoon water for about 5-6 months and then releasing it for the non-monsoon dry season. Or power generation means continuous flow to operate the turbine. দুটো একসাথে পৃথিবীর কোনো জায়গায় সাকসেসফুল হয়নি, হওয়া সম্ভব নয়. Another myth we had the understanding that we have unlimited groundwater. We can exploit the groundwater to any level. And the result is, Professor Rai Chaudhary and Professor De has already explained, and Madam has also explained, leading to alarming lowering of the groundwater table countrywide. I will go to that point also. And we also forgot that environmental cost of polluting rivers. What we did, we took away water from the river and used the water, made it contaminated and then discharged it into the Ganga. Result is Ganga is one of the most polluted rivers of the world. 118 towns and nearly 900 grossly polluted industry along the bank of the river from Haridwar down to Ganga Sagar. They discharge the wastewater till this date. Result is Ganga is, in spite of many pious intention of the government like GAP, Namami Gange, quality has substantially improved, I do admit, but it is not to the level as we expected. Large dam technology has a problem. I have explained. What was the problem? At the point mid-1960s, when I was going to school, the government of India proposed a program of agricultural technological revolution, which we subsequently call Green Revolution. Country-wide water-intensive crops were introduced. আমাদের ট্র্যাডিশনাল ভ্যারাইটি ক্রপগুলোকে রিপ্লেস করে more and more water-intensive crop was Result was some increase in the food production. At that point of time, we used to produce 60 million tons of food grain. Now we produce nearly 270 million tons of food grain. But this large dam technology and canal network did not work to the level of expectation. Because if you go through the documents of the Government of India, they say the dam canal network transmission distribution loss of water is more than 60%. Yes, this is official statement. মানে আপনি ডিভিসিতে জল জমালেন আর হাওড়া হুগলিতে বর্ধমানে যে জলটা এলো, it is only 38% of the what you have stored there. Because evaporation loss you can't control and absorption of the canal bed you can't control. But in the meantime you have changed the cropping pattern. You have replaced the traditional variety crops. Farmers of South India never went for the water intensive crop like rice. What they did, jowar, bajra, ragi and other which is less water intensive. আমাদের understanding হলো সব জায়গায় ধান ফলবে, and we replaced that. Water demand went high, and the canal water did not reach to the farmer. Only 38% reached. The result is the farmer relied on groundwater. And groundwater table came down. I admit that without groundwater, this civilization can't grow. But this must be restricted to the replenishable limit. মানে হচ্ছে যতটা ভেতরে ঢুকছে বর্ষাকালে, আপনি যদি সেই লিমিটের মধ্যে না থাকেন, তাহলে 1000 বছর ধরে জমা একটা গ্রাউন্ড ওয়াটার টেবল, সেটা আমরা প্রায় 30 বছরে শেষ করে দিচ্ছি। I was reading a paper, I was surprised to read. It was by 4 scientists from NASA. It was on the groundwater condition of the Delhi and adjoining area, Delhi, Haryana, Punjab. The period of study was between 2002 to end of the 2008. They said during the 6 years, we have exploited more than 110 billion cubic meter of water. They said that you are threatening the people entirely living in the national capital region. If you continue to do so, Gurgaon and Delhi and adjoining area will have no groundwater in no distant period. My son living in Gurgaon, I know what acute water crisis every year they are facing. Shati has already explained, nearly 85% of the annual water is in agricultural sector. Sir, you had been talking about the solution. We will have to understand that this expensive water intensive agriculture, we can't continue. Professor Raichodhi was talking about the Boro cultivation. This is a dry variety rice we cultivate. We generally plant it during the December and harvest in the April. This is absolutely rainless period. And we go on exploiting the groundwater. আপনার কাছে একটা 1000 বছর ধরে জমা গ্রাউন্ড ওয়াটার ছিল, 30 বছরে তো প্রায় শেষ করে এনেছেন, এর পরে কি হবে? ইউ আর মর্টগেজিং দ্য ফিউচার জেনারেশন ফর ইউর সার্ভাইভাল। আপনাকে সামহোয়ার ইউ উইল হ্যাভ টু মেক এ কম্প্রোমাইজ, উই উইল গো ফর অল্টারনেটিভ ক্রপিং সিস্টেম। সো উইল হ্যাভ টু আন্ডারস্ট্যান্ড। Problem is that this water crisis is largely due to introduction of more and more water intensive crop, replacing the traditional variety crops. আমাদের ফার্মাররা অত্যন্ত বুদ্ধিমত্তার সাথে তারা সব জায়গায় ধান চাষ করতো না। If you expect that we will cultivate basmati rice in Rajasthan and export it to the Europe, you will have to think for something like interlinking of rivers. And at 2002, it was estimated that 5,60,000 crores will be required to implement such a project, which was twice the revenue Government of India that year, more than 10 times what Government of India during the post-independence period. And you are সবচেয়ে বড় যে ব্যারি কমনার wrote a book, এই বইটা I frequently refer. He said 4 laws of ecology governs our existence. First law, he said everything must go somewhere. It is a dynamic system. Everything, whatever you do, you will have to pay a cost. And third law is very important. He said, nature knows the best kind of engineering. Don't try to alter this too much. নেচারকে খুব বেশি অল্টার করার চেষ্টা করো না, তোমার সার্ভাইভালের জন্য যতটুকু মিনিমাম ইন্টারভেনশন দরকার ততটুকু করো, ওর বেশি যেও না। সো উই উইল হ্যাভ টু থিঙ্ক ফর দ্যাট। দ্য ট্র্যাডিশনাল ভ্যারাইটি ইরিগেশন উই টোটালি ডিসঅ্যাপিয়ার্ড। সেন্টার ফর সায়েন্স অ্যান্ড এনভায়রনমেন্ট এই ফিউ ইয়ার্স ব্যাক পাবলিশড এ বুক ডাইং উইস্টম। সেই বইটাতে ও লিখেছিল যে ওরা কত রকমের ইন্ডিয়ান ফার্মার্সরা তারা সমস্ত ইনভেন্ট করেছিলেন, যেখানে হুইচ ওয়ার লোকাল ফার্মার সেন্টার্ড অ্যান্ড কস্ট এফেক্টিভ। দিস টোটালি ডিসঅ্যাপিয়ার্ড। উই লার্জলি রিলাই অন গ্রাউন্ড ওয়াটার অ্যান্ড অন ড্যাম ক্যানাল নেটওয়ার্ক। And the result is carcinic. I was working on the century scale rainfall pattern of Bengal as well as the groundwater depletion. What I find, the government State Water Investigation Department has monitored the groundwater level at 296 blocks. Out of this, 136 blocks ওরা বলছে যে groundwater table is depleting at the rate of 20 centimeter per year. এই গ্রাউন্ড ওয়াটার টেবিলে নেমে গেলে কী কী হয় ওনারা সবাই বলেছেন। আমি একটা কথা বলবো, হাউ রিভার্স ওয়ার পেরিনিয়াল, কী করে নদীগুলোতে সারা বছর জল বইত জানেন? সেটা হচ্ছে যে রেইনফলটা যখন হয় তখন একটা পার্ট অফ দ্য রেইনফল ইজ ইনফিল্ট্রেটেড, ইট রিচার্জেস দ্য গ্রাউন্ড ওয়াটার টেবল। ফ্রম অক্টোবর অনওয়ার্ডস নো রেইনফল, অ্যান্ড দেন দ্য গ্রাউন্ড ওয়াটার লেভেল থেকে একটা ইনভিজিবল ফ্লো নদীর দিকে আসে, দ্যাট হোয়াট উই কল এফ্লুয়েন্ট সিপেজ অফ দি ওয়াটার। When groundwater table goes down, that flow disappears. যার ফলে the Bengal, which was described as proverbially land of rivers, many rivers have disappeared. আপনি এই সময় যদি if you try to walk from here to North Bengal, most of the river you can just walk across, excepting Ganga. More important is, Shati has touched about, the rainfall pattern is fast changing. কীরকম চেঞ্জ হয়েছে? Not that total rainfall has declined. What happened? There is a tendency of unusually concentrated rainfall. মানে যে রেইনফলটা 300 মিলিমিটার সারা মাস ধরে হতো, মেবি দ্যাট ইজ হ্যাপনিং ইন 2 days or 3 days. এই আনইউজুয়ালি কনসেন্ট্রেটেড রেইনফল হলে কী হবে? দেয়ার উইল বি লেস রিচার্জ অফ দি গ্রাউন্ড ওয়াটার অ্যান্ড মোর রান অফ। More runoff means more flood. A less recharge of the groundwater means farmers will not have any water for it. Century scale rainfall data from 1901 to 2012 টাকে অ্যানালিসিস করলে দেখা যাচ্ছে June rainfall has appreciably declined by about 48 millimeter. And there is a tendency of delayed rainfall. এই ডিলেড রেইনফল হলে কী হবে? ইফ ইউ হ্যাভ এনি আন্ডারস্ট্যান্ডিং অ্যাবাউট দ্য ফার্মিং প্র্যাকটিস ইন বেঙ্গল অর এনিওয়ার ইন ইন্ডিয়া, দে ক্রিয়েট এ কাইন্ড অফ নার্সারি বেড। তারা একটা নার্সারি বেড তৈরি করে এপ্রিল মে মাসে দে ওয়েট ফর রেইন টু কাম ইন, অ্যান্ড হোয়েন রেইন কামস দে ট্রান্সপ্লান্ট ইট। দিস ইজ দ্য কমন প্র্যাকটিস ইন থ্রু আউট ইন্ডিয়া। হোয়েন রেইন ইজ ডিলেড, দ্য ট্রান্সপ্লান্টিং ইজ অলসো ডিলেড। দ্যাট রেজাল্ট টু রিডাকশন অফ দি প্রোডাকশন, and the farmers are compelled to rely on groundwater. So we need to think something about our crop calendar. Scientists warn that many rivers, including the Ganga, may go dry by the end of this centuries. And if Ganga goes dry, this civilization will not survive. So what we'll have to do? Very precisely, long distance transfer of water should be avoided as far as possible. Meaning, if you think that you can transfer water from Assam to Tamil Nadu, it is technologically possible, but it is so expensive, water reaching thereon will not be affordable by the farmers. Second is, local water conservation as far as possible should be encouraged. Catch the water where it first drops. Age-old culture of India had been water storage in the dighis and ponds. That has disappeared gradually. The government of India now encouraging, and West Bengal government has also a program of what they call Jal Dharo, Jal Bharo. But problem is that there is a science of excavation of the pond. Three important components are important. One is the depth of the pond must be to the level where from it can get the base flow, or the groundwater table থেকে যেন জলটা আসে. One. Two, it must have inlet of surface water. Surface water যেন ধুয়ে এসে পুকুরে পড়ে. Third, it must have an outlet for excess water. এই তিনটে ঠিকমতো কমপ্লাই যদি না করেন তাহলে পন্ড উইল নট সার্ভাইভ. আরবান এরিয়াতে কী হয়েছে, 4-5টা বিল্ট আপ হয়ে গেছে. এই বিল্ট আপ হওয়ার ফলে দেখবেন যে কলকাতা হ্যাড বিন ডেসক্রাইবড অ্যাজ সিটি অফ দিঘিজ অ্যান্ড পুকুর. আপনি প্লেস নেমের মধ্যে দেখবেন ফরিয়া পুকুর, শ্যাম পুকুর, ঠাকুর পুকুর, মনোহর পুকুর, কত পুকুর, হ্যাঁ, অলমোস্ট মেনি অফ দেম হ্যাভ ডিসঅ্যাপিয়ার্ড. আপনাকে উইল হ্যাভ টু গ্রাউন্ড ওয়াটার টেবল exploitation should be restricted to the limit up to which it is being replenished during the next monsoon season. This climate change has posed a serious challenge for us. So we will have to understand, sir, you had been talking about what is the solution. At that point of time, I remember what Mr. K.R. Narayanan, the former President of India, said, probably his Republic Day speech. He said, when I talk about the revival of the traditional wisdom, I don't oppose modern science and technology. I don't oppose modern science and technology. What I propose is to harmonize the modern science with our traditional knowledge, which our farmer nourished for thousands of years. And there lies the solution. We'll have to understand that we don't need any technology from USA or UK. Post-independent period invited the technology or borrowed the technology from Europe and America. But this country has reached enough to do the needful. With these few words, I stop here. I think I have finished within the time. Thank you all for your patience.
You have finished in time, but we were thinking that you should continue. Today's session was really an eye-opening to all of us. Now, before I request Mr. Rajkumar Agarwal to give vote of thanks, we have Rani.
mementos. We have come towards the end of today's special session, and before we conclude with the vote of thanks, we would like to present mementos to our speakers and guest in chief. I would request our President, Mr. Ramesh Kumar Saraogi ji, to hand over the memento to our guest-in-chief, Dr. Kollan Rudro, Chairman, West Bengal Pollution Control Board.
Okay. Sir, আমার মেমেন্টো বাড়ি নিয়ে গেলে আমার স্ত্রী বলবে একটা শোকেস কিনে আনো.
এত মেমেন্টো হয়ে গেছে.
I would now request Mr. Rajkumar Agrawal, Chairman, Global Trade Subcommittee, to hand over the memento to Professor Dr. Torit Roy Chaudhary, School of Environmental Studies, Jadavpur University. I would request our President once again to hand over the memento to Dr. Swati Nondi Chakraborty, Environment Scientist. Sir, could you please hand over the memento to Dr. Chakraborty? I now request Mr. Rajkumar Agrawal to propose the vote of thanks.
Actually, I want to take lead now.
Dr. Rudro, Professor Day, Professor Ghosh, Professor Rai Chaudhary, Dr. Chakrabarti, Mr. Saraogi, guests and friends.
It's a good idea.
It is
Thank
my most pleasant duty to propose a hearty vote of thanks to our guest in chief, Dr. Kalyan Rudro, Chairman, West Bengal Pollution Control Board. On behalf of the Chamber and on my personal behalf, I would like to express our sincere gratitude to you, sir, for sparing some of your valuable time in gracing this special session on the occasion of the World Water Day organized by the Chamber this afternoon. Next, I would like to thank our respected guests of honor, Professor Seshendu De from the Department of Chemical Engineering, Indian Institute of Technology, Kharagpur, Professor Ashutosh Ghosh, Vice Chancellor, Rani Rashmani Green University, Professor Tarit Rai Chaudhary from the School of Environmental Studies, Jadavpur University, and Dr. Swati Nandi Chakravarti, environment scientist, for their participation and enlightening addresses on the various aspects of the theme groundwater, making the invisible visible. I thank you all once again for kindly agreeing to share your valuable thoughts at today's special session at such a short notice. I would like to express my sincere gratitude to Mr. Ramesh Kumar Sarauge, President of our Chamber, for his wholehearted efforts in organizing today's event. I must also thank our members for making it convenient to attend this session. I also thank our guests for their presence and contributing to the success of this session. Many thanks are also due to the representatives of media, both print and electronic, for their presence at this special session. With these words, I request you all to join me in carrying a hearty vote of thanks to our respected guests with an appreciative acclamation. Thank you, sir.